How important is the impact of the individual in basketball? How can front offices effectively use the individual impact of players to further their own team's accomplishments? By this presentation's end, you will personally know the answers to these questions and the process it takes to get there. But first, let's look at the basis of this study. NBA front offices often resort to calculus to evaluate players in order to further their team's success. This study is meant to analyze the effects of player efficiency, or PER, on the outcome of team wins. I will use optimization of sum of squared error in order to minimize the error and formulate the best linear fit to accurately assess the impact of player efficiency on team victories. The best fit line is meant to minimize the squared error between the predicted value and the actual value. By having a high percentage of accuracy, we can determine if the function can properly predict team wins based on efficiency values. In order to accomplish this with variety and accuracy, I chose 4 different examples of players who had the most individual impact on their own teams. The final product we want to find is the y equals f of x equation that best fits the data set as well as its percent accuracy. Our independent variable, or x variable, is the PER value, and our dependent, or y variable, is team wins. We are looking to find a quadratic equation which satisfies the least sum of squared error between the actual values and the predicted values. Once the data was adjusted for discrepancies, I began calculations on finding the y equals ax squared plus bx plus c equations for each player. Forming a quadratic equation required me to find out the coefficients a, b, and c through a system of normal equations. Normal equations are, in simple terms, minimized equations which account for to give the probable coefficients of the actual quadratic fit. The system of equations is given by the following formula. In this particular scenario, the xi represents the PER value at a specific point. The yi value represents team wins value at a specific point, and the ni value represents the total number of seasons. By finding the summation values for all that apply, I calculated the a, b, and c coefficients for each player to form 4 quadratic functions. In order to determine the accuracy of the predicted fit functions, I subtracted the summation of the squared actual team wins by the total squared error from the actual value. With this value, I divided it by the summation of team win values and multiplied that value by 100 to find the percentage accuracy of the parabolic fit with the data. Since the function was proven to be accurate, we can take the derivative of each of the 4 functions and compare the rate at which the team wins are increasing or decreasing at certain PER points and to compare a possible maximum value of team victories. Now let's look at the actual results. First, we look at LeBron James, the best player of the 21st century. As seen on the table and the graph, LeBron's team win total generally trends up when his PER is higher or farther to the right on the graph. The calculations told a similar story and produced the predicted parabolic fit as y equals 0.0478x squared plus 0.553x plus 9.482 with a percentage accuracy of around 98%. When it comes to evaluating the data through derivatives, the second derivative is positive, meaning that the fit line will have a minimum value. The minimum is not a possible x value, as the first derivative will continually increase as long as the second derivative is positive. Now we examine Chris Paul, one of the best point guards of all time. Noticeably, his win totals changed following his departure to a better team, while he maintained his strong PER values. The calculations of the linear fit reflected those changes through the function y equals negative 7.787x squared plus 43.066x minus 530.894, with a percentage accuracy of around 99%. Different than LeBron, Paul's second derivative is negative, meaning there is a maximum value. The maximum is found at the point 27.361, 58.267, which is the highest projected win total. The third case is Kevin Garnett, one of the best big men of the 2000s. His trends are very reflective of his team changes, as when he took a smaller role, his PER fell, but his team wins increased. The predicted fit equation is y equals negative 0.189x squared plus 9.632x minus 69.046, with a percentage accuracy of around 94% and does very well, accounting for notable outliers. The second derivative is negative, meaning Garnett had a maximum predicted win total at 25.481, 53.673. The last study was of the greatest of all time, Michael Jordan. He was the most interesting case as his higher PER values often coincided with lower win totals, creating some irregularity. The predicted fit equation for Jordan was y equals negative 1.206x squared plus 68.214x minus 889.432, with a 95% accuracy despite the odd data. The second derivative was also negative, and the maximum was much higher at 75.151 wins. Overall, each study gave differing results and provide clarity into finding information unique to particular players. In conclusion, NBA front offices use mathematics such as these studies to provide insight into their own decision-making. This was very successful, and I thank you for listening.